Hi everyone, I'm Gabriel from ARM. Welcome to this hands-on tutorial where we'll explore ARM's neural supersampling technology in the Unreal Engine. Neural supersampling, or NSS, is ARM's AI-powered upscaling solution that's designed specifically for mobile platforms. What makes NSS special is that it can take a frame rendered at 540p resolution and intelligently upscale it to a crisp 1080p quality, delivering massive GPU workload savings. This means developers can either boost frame rates, improve visual quality, or extend battery life on mobile devices. Now, since dedicated neural accelerators aren't available in current hardware yet, we need to use ML extensions for Vulkan with emulation layers. These emulation layers simulate the behavior of future neural hardware, allowing us to test and develop with NSS today on any Vulkan-capable GPU. Think of it as a preview of what's coming to mobile gaming in 2026. The setup involves three key components: the Vulkan SDK with its configurator, the ML emulation layers that simulate the neural hardware, and the NSS plugin itself for the Unreal Engine. To follow along, you will need to be on Windows 11, have Unreal Engine 5.5 installed, as well as Visual Studio 2022 with desktop development with C++, and the .NET desktop development installed. Let's dive in and get this running step by step. Now to start off, we need to download the NSS plugin as well as the ML extensions for Vulkan plugin for the Unreal Engine. Both of these can be found in our GitHub repos. You can see the link on the screen or follow it in the description below. So go ahead and on the right, you're going to go to the releases and just follow the latest release. Go ahead and download this top zip file. And then go ahead to the ML extensions and do the same thing. Once it's downloaded, let's go ahead and extract them. It doesn't exactly matter where you extract them to. It just needs to be somewhere that it's easy to remember. Now let's go ahead and we are just going to move these two extracted folders anywhere you'd like. I just don't want it in my downloads folder. For ease of use, I'm going to move it into my Unreal projects folder, just in the default location. And I'm going to create a new folder, just titled NSS plugins. Now we need to download the Vulkan SDK. Again, you can find the link on the screen as well as in the description. It doesn't matter which one you download. You can just go with the latest version. I am downloading 1.4.321.1, but if it's a later version, it should have no problem. Additionally, it should have no problem if it's an earlier version. Once it's finished downloading, let's go ahead and run it. And when you get to the screen where you select components, you can just leave them at their default settings. If you need anything, go ahead and select it, but for the purpose of this tutorial, we do not. Go ahead, click Next, accept the license, and install. Once you get here, either check Run the configurator and then Finish, or if you don't do that, you can just run the Vulkan configurator from your start menu. Now we first want to go to the layers location and we need to pick out the folder. I've done this before, so it remembers where I had it in the last time I did this. But based on where I extracted it, we're going to go to the Unreal projects, NSS plugins, the one that begins with NNE runtime, and select the one that starts with ML emulation layer. And go ahead and select this folder. And you should see a pop-up that says 2-layer manifests added. Go ahead and click OK. And you will see this new entry. It'll have your entire location or your entire folder path as well as the 2 layers. Now go back to the Vulkan Loader Management tab. Select Validation if it is not already selected. And then we should in the window below, at the very bottom, we should see our new layers. So first step, let's go ahead and enable both of these. And then let's move the emulation layer directly below screenshot and tensor directly below graph. Now this is important. Graph needs to be right above tensor. Later on, if you get any errors, this may be the cause. And while you're doing all of this, you're going to want to leave the configurator running in the background, as long as you're trying to do anything with NSS in Unreal. Next, let's open up the Unreal Engine, and it is important that we are using Unreal 5.5. The minor version doesn't matter as long as it's 5.5. Now go to the Games tab, and we are going to be creating a project using the third-person template with C++ set as the project default. Go ahead and name this whatever you'd like, and create. Now, once your project is loaded, go ahead and open up either Visual Studio or, in my case, OpenWriter, whichever IDE you happen to be using. All right, and once your IDE finishes loading, let's go and actually close down our Unreal Editor. And once it's fully shut down, we need to do a build. So let's just go ahead and build solution. Now, after it's finished building, go ahead and open your project back up. Now we need to set the default RHI to Vulkan. So go ahead, go to Edit, Project Settings, and then on the left, scroll down to the Platforms section and select Windows. And then under Targeted RHIs, change that to Vulkan. It will prompt you on the bottom right to restart now. You can't see it because my window is blocking that on the bottom right, but don't restart. Instead, just close it down because this is going to be where we install the plugins. Go ahead and close out your IDE if you have it open as well. So let's go to our location where we copied our plugins, and we need to now copy these into a plugins folder in our project directory. So go ahead, create a new folder and name it plugins, and paste these right in there. And then from here, we're going to go ahead, we're going to reopen our project. You'll most likely get a pop-up like this where it says it's missing modules, and it says the following modules are missing or built with a different engine version. If you get this, just go ahead and click yes when it asks, would you like to rebuild them? Now that rebuild step should have taken care of actually rebuilding it from source, which is something we need to do. But just to be safe, or if you didn't get that prompt and you just want to ensure that everything goes correctly, go ahead and open your IDE. All right, and once your IDE finishes loading, go ahead and close out of your Unreal Editor again. And once it's fully shut down, we need to go to Build, and we're going to rebuild the solution. And once that is done, let's go ahead and reopen our project. Now let's go and verify that our plugins are installed and activated. You just go to Edit, Plugins. First, we're going to type in NSS. Yep, Neural Super Sampling. And then you can type in Vulkan. And you should get the one that starts with NNE runtime. So we're good there. Now let's go and verify that NSS is actually running properly. So the console command is show flag dot visualize temporal upscaler space 1. And you should see third-party temporal upscaler NSS. So we are good there. And if you run the same command but 0, that'll hide that. Now let's see a real-time view of all of the processed outputs. So the command is r.nss.debug space 2. And here you are. All of the outputs visualized perfectly. I will provide a link in the description where you can find out documentation that explains more about what is going on here. So next, we're going to install the ARM Performance Studio to be able to use RenderDoc to help profile what's going on right here. So go to the ARM Performance Studio download page and then download the Windows version. Go ahead and save it. And once that finishes, let's go and run it. You can just leave all these settings at their default and then next. Once complete, we need to go into our settings. So edit project settings and then scroll to the very bottom where you get to the plugin section and find RenderDoc. So there's two things. One, we need to find a certain executable to paste into the RenderDoc executable path. So let's go to its default location, which is going to be on your C drive or whichever drive you installed it on. Program files, ARM Performance Studio, and then RenderDoc for ARM GPUs. And it needs to be the directory that has the qrenderdoc.exe file in it. So let's go ahead and copy this location. And then additionally, we need to check auto attach on startup. This one's important. If you forget to do this, it won't even acknowledge the Unreal Engine in the first place. So go ahead and check it. And it should now prompt you to restart it. So go ahead and restart. So there are going to be two ways that you can capture frame data. So the first is there will be an icon at the top right. Let me go full screen. If you don't see it in the top right, most likely it's buried in a drop-down command. I have everything upscaled quite high so that it'll capture properly and you don't see everything as tiny. So you can just go ahead and click that icon and it'll capture the next frame data and launch the RenderDoc UI. And you can see here it has all that frame data. I do want to warn you, if it is nested, that can cause some problems. So if it's nested like this and you click the RenderDoc icon at the bottom, it'll actually only capture the frame data for that little GUI section. As you can see here, not quite as helpful, just something to be aware of. And then the other way you can capture is, first off, making sure that it is attached to the running instance. If you're doing it this way, so you would go File, Attach to Running Instance, select Unreal and say Connect to App. And then you can just say Capture Frames Immediately. And there you go. Now, of course, it's not really useful when it's capturing everything. You'd most likely be running this in an actual project while it's in play mode. In RenderDoc, there's a lot of data to go over. And so this is where the RenderDoc documentation will really come in handy. So if you find this valuable, go ahead and reference this documentation. And there you have it, neural supersampling running live in Unreal Engine, giving us a glimpse into the future of mobile graphics. We've successfully set up the emulation environment and seen real-time AI upscaling in action. This is just the beginning of what's possible with ARM's neural technology. If you're interested in diving deeper, I highly recommend checking out the ARM Developer Program, where you'll find comprehensive resources, documentation, and community support for all things ARM development. This tutorial was based on an official learning path from learn.arm.com. If you'd like to recreate these steps using a text-based resource, go ahead and check it out. For those working on cutting-edge projects, don't forget about ARM's Early Access program, which gives developers hands-on experience with upcoming technologies before they hit the market. It's a great way to stay ahead of the curve and stay on top of future hardware. You can find links to all of these in the description below. Thanks for watching, and happy developing with ARM's neural graphics technology.